All Peterbilt truck models, excluding the 387, that have the RAMI multiband antenna system on it, can be verified using the following troubleshooting steps that we're going to demonstrate on this Peterbilt 379 model. Like on all trucks, the first thing we start with is the antenna whips themselves. So that's where we'll start. To remove the antenna, use a 1/2 inch and 9/16 inch wrench. Now we will go inside and I'll show you how to troubleshoot the antenna. The most common problem found is a damaged antenna. And the place where it's usually damaged is where the wire is soldered to the ferrule portion at the bottom of the antenna. So to check continuity of this, we're going to remove the cap and then cut a couple little slots at the tip of the heat shrink. We'll carefully peel this back. We want to be careful not to pull the wire out of the slot and let the top portion unspring, because this would change the electrical length for the CB frequencies. Now we're going to, because there's a protective coating on the wire, we got to either sand or lightly scrape off that coating to expose the bare wire. Now it helps if you use some type of alligator clip to connect to this point. And we're going to check for DC continuity from the tip down to the ferrule end of the antenna. And then while we're doing this, we're going to also want to twist and flex that bottom portion to make sure we don't have an intermittent break. After verifying the antennas, we will now check for good grounding from the mirror brackets to chassis ground. But before we can do this, we're going to have to go inside the cab and disconnect all the radio cables to the multiplexer box and the antenna cables, which are connected right at the multiplexer box also. Now we're going to disconnect the radio cables. Get the CB cable disconnected. AM/FM cable, and then if you have the cell phone option, you also disconnect the cell phone cable. Now we're going to want to take this cover off so we can disconnect the antenna cables right at the multiplexer box. So right up above you should see the multiplexer box, and you just unscrew the two antenna cables which come out the end of the box. Now we're ready to troubleshoot for good grounding. We're going to test for DC continuity from the mirror bracket assembly to chassis ground. First, down at the frame, let's make sure we get good chassis ground. Then we're going to come up here and at the bracket assembly, preferably where our cable, the ground portion, is touching on the bracket. This is a good place to touch because then we know we got a good connection there. And we're looking for a DC continuity reading of less than 5 ohms. If after checking both the driver and passenger side we have more than 5 ohms, we're going to want to start troubleshooting from the bracket all the way down to the frame, looking for corrosion or a loose connection. Now we will go inside the cab and verify the bracket assembly and cable assembly that runs to the multiplexer box. Now from inside the truck, with our antenna cables exposed, we can check DC continuity tests from the cables to the cable assembly at the bracket. Open up the door so I can reach things a little easier. The first step is we're going to go from the center conductor of the antenna cable assembly. In the other lead, we're going to connect to the standoff nut, which is the center conductor on this cable assembly, and we're looking for DC continuity. Next, we're going to check from the center conductor on the inside again to the ground portion of the cable assembly on the outside, and we're looking for no DC continuity. Then last, we're going to go from the ground portion, the outer shell of the connector inside, to the ground portion on the outside, and we're looking for DC continuity. If a problem is found, we're going to want to check for damage on the antenna cable assembly from the inside all the way out to the bracket assembly. And then we're also going to want to check for a possible short or a bad connection at the bracket assembly itself. The last component we're going to check in the system is the multiplexer box. We're checking this last because it's been proven to be the least likely cause of any issues. So the first thing we're going to do is make sure all the cables are still disconnected from the box, and then we can start troubleshooting it. Now we want all cables still disconnected from the box, and then we can start our testing. Testing through the CB cable is no longer possible because internal components do not provide a DC path. So all testing can be done from the AM/FM cable to the connectors on the side of the multiplexer box. So first, we're going to connect to the center conductor of the AM/FM cable, and then our other lead will go to the center conductor on the box, which is marked antenna cable, and we want DC continuity. The next check, we'll leave the center conductor of the AM/FM cable connected, and we'll go to the outer shell of the connector on the box, and we want no DC continuity. The last check, we'll go from the outer shell of the AM/FM cable, ground portion, to the outer shell connector on the box, and we want DC continuity. If a failure is found after checking both sides, if you have a dual system, or the one side if you have a single whip system, the first thing to check would be any damage on the AM/FM cable that runs to the multiplexer box, and if no damage is found, further evaluation of the multiplexer box would be required. Now we're going to go over some advanced troubleshooting techniques. And this first one is going to be checking the antenna cable assembly from the box out to the antenna, and we're going to check for a pinched or damaged cable that a DC continuity test was unable to pick up. The cable could be pinched or damaged to the point where it could change the impedance of the cable, and it could definitely affect your CB performance. So for this test, you're going to need an SWR meter, and we're going to have to do the test from the antenna cables at the multiplexer box. Once inside the truck, we're going to have our SWR meter set up so the center of the frequency band is 27.17 megahertz, which is the center of the CB frequency band, and then put a plus or minus 5 megahertz span on it. We're going to connect the antenna cable to the meter, and you should see a resonant dip near 27 megahertz, and you're looking for at least a 2-to-1 or better SWR reading. You're going to check this both sides, both antennas, and if there is a problem on one side, you're going to see that the SWR is going to be higher, like 5-to-1, 6-to-1 or higher, and it may be shifted way over to 22, 23 megahertz. this will indicate that there's a problem. Now we're going to go back outside and we're going to show another troubleshooting technique on some grounding of the mirror brackets. This next technique, we're going to verify that we have a good connection in the upper mirror arm to the door frame or to the cab. In most models, we have good connection at the lower and upper. But if it's only in the lower and not in the upper, it takes a different ground path and then it offers a slightly different ground plane for CB frequencies. And this definitely can affect your CB performance. So what we're going to do is loosen up the lower arm and disconnect any cables if there's any in there. And we're going to carefully pull that away so it's not touching the cab. And then we're going to take a DC continuity reading from this lower arm, have it go through the upper arm into chassis ground. And we're looking for a DC continuity reading of less than 5 ohms. Let's find a good ground on the frame. We're going to carefully pull this out. And we're looking for less than 5 ohms. If we have a reading of more than 5 ohms, then we're going to want to troubleshoot looking for corrosion or loose connections from the lower arm up through the top and all the way to the frame.